25 million years ago, long before the first humans walked the Earth, a massive crack tore through the crust of our planet in what is now the heart of Siberia. Over countless ages, that fracture slowly filled with water, creating something far more ancient and far more mysterious than an ordinary lake. This is Lake Baikal, the oldest and deepest lake on Earth, and one of the last truly unexplored frontiers on our own planet. What scientists have discovered at its very bottom in recent years is forcing them to rewrite what they thought they knew about life in extreme environments. Picture a body of water so vast and so deep that it holds nearly 1/5 of all the unfrozen fresh water on the surface of the entire world. Lake Baikal reaches a maximum depth of 1,642 meters, plunging farther down than the height of the tallest skyscrapers stacked on top of each other multiple times. It stretches 636 kilometers from end to end, longer than the distance between major cities many Americans drive in a single day. Its volume is so enormous that if you combined all 5 of the Great Lakes in North America, they would still not be enough to fill it completely. 23,615 cubic kilometers of water sit here in complete isolation from the rest of the world's oceans and rivers. Most lakes we know were carved out by glaciers during the last ice age. Lake Baikal is different. It lies in an active tectonic rift zone where the Earth's crust is still being pulled apart, even today, at a rate of roughly 2 centimeters each year. In geological time, that movement is remarkably fast. Some researchers believe that given enough time, this rift could eventually split the continent and form a brand new ocean right here in Siberia. Right now, it offers us a rare glimpse into the very beginning of how oceans are born. Because this lake has existed for 25 to 30 million years without ever freezing solid, even during the harshest ice ages, it became a perfect natural laboratory for life. Species trapped here had nowhere else to go. They could not migrate to warmer waters or escape to other habitats. They had to adapt or disappear. The result is one of the highest rates of endemism found anywhere on Earth. More than 80% of the animals and plants living in Lake Baikal exist nowhere else on the planet. Among these unique inhabitants is the Baikal seal, known locally as the nerpa, the only species of freshwater seal in the entire world. Its ancestors somehow found their way into this isolated basin millions of years ago and evolved separately from their ocean-dwelling relatives. There is also the golomyanka, a nearly transparent fish that makes up a huge portion of the lake's biomass. Unlike most fish, the golomyanka gives birth to live young rather than laying eggs. Its body contains so much oil that if brought to the surface too quickly, it can literally burst from the sudden change in pressure. These are only 2 examples among thousands of species that have evolved in total darkness and crushing pressure over millions of years of isolation. The shallow waters and the surface already tell an incredible story of survival and adaptation. Yet the real surprises, the discoveries that have genuinely shocked researchers, begin much farther down, where sunlight has never reached and where the pressure would crush most living things in an instant. Recent expeditions, equipped with modern submersibles and advanced sensors, have finally begun to explore these extreme depths. What they found on the lake floor was not the barren, lifeless zone many expected. Instead, they encountered thriving ecosystems, strange geological formations and organisms that challenge our understanding of where and how life can exist. These findings are not just interesting scientific footnotes. They may hold clues about how life could survive in the hidden oceans beneath the icy surfaces of moons like Europa and Enceladus. To truly grasp what exists at those crushing depths, we must first understand the immense geological forces that created Lake Baikal and continue to reshape it even today. This lake does not sit in a quiet ancient basin like most bodies of water on Earth. It occupies one of the most active tectonic rift zones on the planet, a place where the continents themselves are slowly being torn apart. The Baikal Rift has been widening for millions of years, and the process shows no sign of stopping. Scientists monitoring the region have measured steady movement that in geological terms happens at a remarkable pace. Over time, This slow but relentless separation could transform the rift into a new ocean basin, splitting the landmass in two and flooding the depression with seawater from distant oceans. What we see today is therefore not a finished landscape, but the earliest visible stage of ocean birth, happening right before our eyes in the middle of Siberia. This ongoing geological activity has profound consequences for everything that lives in the lake. The constant shifting of the crust creates deep fractures and hydrothermal vents on the lake floor, where hot mineral-rich water rises from below. These vents act as oases of life in an otherwise dark and cold environment, providing energy and nutrients to entire communities of organisms that never see sunlight. The same forces that are pulling the continent apart are also responsible for the extraordinary depth of the lake, allowing it to reach more than 1,600 meters below the surface. As the rift continues to open, the lake grows deeper and its unique ecosystem evolves in response to changing conditions at the bottom. Because the rift has existed for so long, Lake Baikal has remained remarkably stable in some ways, while changing dramatically in others. It survived multiple ice ages that wiped out countless other lakes around the world. During those frozen periods, the lake never completely iced over, preserving a continuous habitat for ancient lineages of life. Many of the species we find today are living fossils, direct descendants of creatures that swam in these waters when the rift was still young. Their genetic lines have remained unbroken for millions of years, giving researchers an unparalleled window into the deep past of our planet. Yet this stability at the surface masks intense activity far below. Earthquakes are common in the region, sometimes strong enough to be felt across hundreds of kilometers. Underwater landslides and sediment flows regularly reshape the lake floor, creating new habitats and burying old ones. These dynamic processes mean that the bottom of Lake Baikal is not a static environment, but a constantly changing world where geology and biology interact in ways scientists are only beginning to understand. The same forces driving the rift also bring fresh minerals and chemicals up from deep within the earth, fueling microbial life that forms the base of the entire deep water food chain. It is this combination of extreme depth, ongoing tectonic movement, and ancient isolation that makes the lake floor such a compelling place for exploration. For decades, researchers could only speculate about what might exist in the perpetual darkness more than a kilometer below the surface. Early expeditions using basic equipment returned with tantalizing hints of unusual life, but the technology of the time could not reach the deepest zones or stay long enough to observe them properly. Only in recent years have advanced submersibles, remotely operated vehicles, and high-resolution sensors allowed scientists to descend all the way to the bottom and stay there long enough to make detailed observations and collect samples. What they encountered when they finally reached those depths challenged many long-held assumptions about life in extreme environments. Instead of a barren, lifeless plain, they found thriving biological communities clustered around hydrothermal vents and cold seeps. They discovered new species never seen before, some of them so different from known organisms that they required entirely new classifications. They mapped geological formations that revealed the ongoing birth of the rift in real time, including fresh fractures and mineral deposits forming before their eyes. These discoveries did more than simply add to our catalogue of life on Earth. They provided concrete evidence that complex ecosystems can flourish in places previously considered too hostile for anything beyond the simplest microbes. The implications extend far beyond Lake Baikal itself. The conditions at the bottom of this ancient rift lake share striking similarities with environments believed to exist on icy moons in our outer solar system. If life can thrive here in total darkness, under immense pressure, and with limited energy sources, then similar processes might support life in the hidden oceans beneath the frozen surfaces of Europa or Enceladus. Lake Baikal has therefore become more than a remarkable natural wonder on our own planet. It has become a living laboratory for understanding how life might exist elsewhere in the universe. As the expeditions continued, researchers began to piece together a more complete picture of the deep lake ecosystem. They found layers of sediment that preserved records of climate change stretching back hundreds of thousands of years. They identified previously unknown species of sponges, amphipods, and microorganisms adapted to the unique chemistry of the rift floor. They documented the way nutrients and energy flow through the deep water community, from the hydrothermal vents upward through the food chain to larger predators. Each new finding added another piece to a puzzle that is still far from complete, yet already reveals a world more vibrant and more resilient than anyone had imagined. Among the most striking findings were entire colonies of microorganisms thriving directly around the hydrothermal vents, where scalding hot water, rich in minerals and toxic gases, pours out from beneath the crust. These tiny life forms do not depend on sunlight or photosynthesis like almost every other ecosystem on Earth. Instead, they practice chemosynthesis, drawing energy directly from the chemical reactions between the vent fluids and the surrounding water. This discovery fundamentally changed how scientists think about the boundaries of life, because it proved that complex biological communities can exist in complete darkness, under pressures that would instantly crush a human being, and at temperatures that would cook most surface organisms in seconds. From these microbial mats, the energy flows upward through layers of specialized creatures, including dense fields of giant sponges that filter the water for nutrients, strange shrimp like amphipods that swarm in the warm currents, and even fish that have adapted to the perpetual night and crushing weight of the deep. Expeditions using manned submersibles and remotely operated vehicles have brought back high-definition video and physical samples that reveal a level of biodiversity no one expected at such depths. Researchers have catalogued new species of invertebrates and microorganisms that appear to have evolved in isolation for millions of years, developing unique adaptations to the chemical soup created by the rift. Some of these organisms produce compounds that are now being studied for potential medical or industrial uses because they have survived for so long in conditions that would destroy ordinary life. The sediment layers on the lake floor have also yielded an extraordinary record of past climates, with cores containing microscopic fossils and chemical signatures that stretch back hundreds of thousands of years, allowing scientists to reconstruct how the region responded to ice ages and warming periods long before human civilization began. What makes these findings particularly powerful is the way they mirror environments thought to exist elsewhere in our solar system. The combination of liquid water, extreme pressure, chemical energy sources, and complete darkness at the bottom of Lake Baikal closely resembles the conditions believed to exist in the subsurface oceans of Jupiter's moon Europa and Saturn's moon Enceladus. If life can flourish here on Earth in a rift lake that has been isolated for 25 million years, then similar processes could potentially support life in those distant hidden seas. Lake Baikal has therefore become a critical reference point for astrobiologists planning future missions to explore icy worlds. Every new organism discovered here provides another data point in the ongoing search for life beyond our planet. The human story of exploration adds another layer to the narrative. Teams of Russian and international scientists have spent years preparing equipment that can withstand the pressure and cold of the deepest zones. They have lowered cameras and sampling devices through holes cut in the winter ice and piloted submersibles through the inky blackness, guided only by sonar and faint lights. Each successful dive has returned with images and data that previous generations of researchers could only dream of obtaining. These expeditions have required extraordinary patience and technical skill because the lake is remote, the weather can turn dangerous in minutes, and the technical challenges of working at such depths are immense. Yet the reward has been a steadily growing understanding of one of Earth's last great unknowns. As the picture of the deep lake ecosystem becomes clearer, researchers are also confronting new questions. How do these isolated communities respond to changes in the water chemistry caused by human activity or natural shifts in the rift? What happens to the delicate balance of life when sediment from the surrounding mountains washes in during heavy rains or when seismic events disturb the lake floor? The answers matter not only for the future of Lake Baikal itself, but for our broader understanding of how extreme environments function and how resilient life can be when pushed to its limits. The lake is no longer viewed simply as a beautiful natural wonder or a source of clean water. It has become a living archive of planetary history and a testing ground for ideas about life in places we cannot yet reach directly. The more scientists learn, the more they realize how much remains unknown. The deepest zones of the lake have been visited only a handful of times, and vast areas of the bottom remain unmapped in detail. New expeditions are already being planned with even more advanced technology that will allow longer stays and more precise measurements. Each return to the surface brings fresh excitement and new puzzles, because every dive seems to reveal something unexpected, whether it is a previously unknown species, a strange geological formation, or evidence of processes that scientists had not anticipated. This sense of continual discovery keeps the research community engaged and reminds everyone involved that even on a planet we have studied for centuries, there are still places where nature can surprise us. What these expeditions have revealed goes far beyond simple lists of new species or interesting geological formations. At the deepest points, researchers found thriving mats of microorganisms clustered around the vents, where superheated water rich in dissolved minerals and gases rises from below the crust. These microbes survive without any sunlight by harnessing chemical energy released when the vent fluids mix with the cold lake water. This process, known as chemosynthesis, supports entire food webs that have no connection to the sunlit world above. From these microbial foundations grow fields of giant sponges that wave gently in the faint currents, strange crustaceans that gather in dense swarms, and fish specially adapted to the total darkness and enormous pressure. Each of these organisms represents millions of years of evolution in complete isolation, and many of them have developed biological strategies never seen in surface ecosystems. The human effort required to reach these depths has been just as remarkable as the discoveries themselves. Teams have cut holes through thick winter ice, lowered heavy equipment into the freezing water, and piloted submersibles through blackness so complete that the only light comes from the vehicles themselves. Every dive demands careful planning because the pressure at the bottom can exceed 160 atmospheres, and any equipment failure could mean the loss of irreplaceable data or even the vehicle. Yet the scientists keep returning because each successful mission brings back images and samples that rewrite textbooks. High-definition cameras have captured scenes of life flourishing where no one expected it to exist, and sediment cores have preserved chemical records of ancient climates that help us understand how our planet responded to past changes in temperature and ice cover. These findings have also opened new lines of thinking about life beyond Earth. The conditions at the bottom of Lake Baikal, with its liquid water, extreme pressure chemical energy sources, and complete absence of sunlight, closely resemble the environments thought to exist beneath the icy shells of certain moons orbiting Jupiter and Saturn. If complex communities can thrive here for millions of years in total isolation, then similar processes might allow life to exist in those distant hidden oceans as well. Lake Baikal has therefore become more than a unique natural feature on our own world. It now serves as a living reference point for researchers who study the possibility of life elsewhere in the solar system and who plan future missions to explore those icy worlds directly. At the same time, the research has raised important new questions about the future of the lake itself. How will the deep communities respond if the chemistry of the water changes because of human activity or natural shifts in the rift? What happens when large amounts of sediment wash in from the surrounding mountains during heavy rains, or when earthquakes disturb the lake floor? These questions matter because Lake Baikal is not a static museum piece, but a dynamic system that continues to evolve. The same geological forces that created the rift and continue to widen it are still actively shaping the habitat at the bottom, and any significant change could affect the delicate balance of life that has existed there for so long. The sense of ongoing discovery remains strong among the research teams. Even after multiple successful expeditions, large areas of the deepest zones have still never been visited, and new surprises appear with almost every dive. Scientists speak of the excitement that comes from knowing that the next descent could reveal something entirely unexpected, whether it is a previously unknown species, a strange geological structure, or evidence of processes they had not anticipated. This feeling of continual exploration keeps the work alive and reminds everyone involved that even after centuries of scientific study, our own planet still holds places where nature can astonish us with its creativity and resilience. What these expeditions have revealed goes far beyond simple lists of new species or interesting geological formations. At the deepest points, researchers found thriving mats of microorganisms clustered around the vents, where superheated water rich in dissolved minerals and gases rises from below the crust. These microbes survive without any sunlight by harnessing chemical energy released when the vent fluids mix with the cold lake water. This process, known as chemosynthesis, supports entire food webs that have no connection to the sunlit world above. From these microbial foundations grow fields of giant sponges that wave gently in the faint currents, strange crustaceans that gather in dense swarms, and fish specially adapted to the total darkness and enormous pressure. Each of these organisms represents millions of years of evolution in complete isolation, and many of them have developed biological strategies never seen in surface ecosystems. The human effort required to reach these depths has been just as remarkable as the discoveries themselves. Teams have cut holes through thick winter ice, lowered heavy equipment into the freezing water, and piloted submersibles through blackness so complete that the only light comes from the vehicles themselves. Every dive demands careful planning because the pressure at the bottom can exceed 160 atmospheres, and any equipment failure could mean the loss of irreplaceable data or even the vehicle. Yet the scientists keep returning because each successful mission brings back images and samples that rewrite textbooks. High-definition cameras have captured scenes of life flourishing where no one expected it to exist, and sediment cores have preserved chemical records of ancient climates that help us understand how our planet responded to past changes in temperature and ice cover. These findings have also opened new lines of thinking about life beyond Earth. The conditions at the bottom of Lake Baikal, with its liquid water, extreme pressure chemical energy sources, and complete absence of sunlight, closely resemble the environments thought to exist beneath the icy shells of certain moons orbiting Jupiter and Saturn. If complex communities can thrive here for millions of years in total isolation, then similar processes might allow life to exist in those distant hidden oceans as well. Lake Baikal has therefore become more than a unique natural feature on our own world. It now serves as a living reference point for researchers who study the possibility of life elsewhere in the solar system and who plan future missions to explore those icy worlds directly. At the same time, the research has raised important new questions about the future of the lake itself. How will the deep communities respond if the chemistry of the water changes because of human activity or natural shifts in the rift? What happens when large amounts of sediment wash in from the surrounding mountains during heavy rains, or when earthquakes disturb the lake floor? These questions matter because Lake Baikal is not a static museum piece, but a dynamic system that continues to evolve. The same geological forces that created the rift and continue to widen it are still actively shaping the habitat at the bottom, and any significant change could affect the delicate balance of life that has existed there for so long. The sense of ongoing discovery remains strong among the research teams. Even after multiple successful expeditions, large areas of the deepest zones have still never been visited, and new surprises appear with almost every dive. Scientists speak of the excitement that comes from knowing that the next descent could reveal something entirely unexpected, whether it is a previously unknown species, a strange geological structure, or evidence of processes they had not anticipated. This feeling of continual exploration keeps the work alive and reminds everyone involved that even after centuries of scientific study, our own planet still holds places where nature can astonish us with its creativity and resilience. When we step back and consider everything that has been learned about the bottom of Lake Baikal, the picture that emerges is both humbling and inspiring. Here, in a single body of water, scientists have found evidence of life thriving under conditions once thought impossible, evidence of geological processes that are still actively reshaping the planet, and a living record of climate changes stretching back hundreds of thousands of years. All of this exists in a place most people will never see. Yet it affects our understanding of the world we inhabit and the possibilities that may exist beyond it. The deep lake has shown us that even on a planet we believe we know well, there remain frontiers where life finds ways to endure, and where the Earth continues to reveal new chapters of its long story. The resilience displayed by the organisms living at these depths carries a quiet but powerful message. These creatures have survived for millions of years in total darkness, under pressures that would destroy most known life, and with energy sources that have nothing to do with the sun. Their existence reminds us that life is far more adaptable and far more persistent than we often assume. In a time when many worry about the future of our own environment, this hidden world beneath the surface of an ancient Siberian lake offers a different perspective. It shows that life can endure in the most unlikely settings, and that the processes supporting it can persist for geological ages if the fundamental conditions remain in place. At the same time, the story of Lake Baikal underscores how much we still have to learn about our own home. Despite all the advances in technology and all the expeditions that have returned with new data, large portions of the deepest zones remain unexplored. New species, new geological features, and new insights into how life and the Earth interact continue to appear with each careful descent. This ongoing process of discovery keeps science honest and keeps us aware that certainty is always temporary when we study something as complex and ancient as our planet. The lake does not simply provide answers. It also keeps asking questions that push researchers to look deeper and think more broadly about what is possible. For those who have dedicated years of their lives to studying this place, the work is more than a scientific pursuit. It becomes a form of respect for something far older and far more enduring than human civilization. Standing on the ice in winter, or watching the submersible lights fade into the darkness, they are confronting a world that existed long before us and will likely continue long after we are gone. That perspective changes how people think about their own place in time and about the responsibility that comes with being able to explore and understand such a remarkable system. The lake becomes both a teacher and a reminder of how much remains beyond our immediate reach. In the end, what makes Lake Baikal so compelling is not only what has been found, but what it represents. It is a place where the boundaries between geology and biology blur, where the past and the present meet, and where the familiar rules of surface life no longer fully apply. It is also a place that connects our small human efforts to something much larger, the ongoing story of a living planet, and the possibility that similar stories may be unfolding in hidden places across the solar system. The darkness at the bottom of the lake is not empty. It is full of life, full of history, and full of the quiet persistence that has allowed life to continue on Earth for billions of years. That is the real discovery, and it is one that continues to unfold with every new expedition that returns to the surface, carrying new questions and new wonder.